My name is Ann Heather Welch, and I'm a junior in the Arizona Western College Radiologic Technology program. My research project stems from a project I did for a class about advancements in our technology. The assignment led me down a path to something which I'm actually more curious about. For my research project, I'm diving into the idea that when faced with new medical information, patient perception could have more impact than facts. And would there then be negative consequences to our health based on those incorrect perceptions? Is it more important to be safe or to feel safe? X-rays were invented in the late 1800s, and high-dose radiation resulted in burns, cancers, and deaths. Lead and other metals were discovered as an effective barrier to this helpful but potentially harmful radiation. Lead aprons have been commonplace in medical practice since the 1950s, and advancements in digital imaging have helped cut patient dose by 95% since the old days of radiology. But safety from the direct primary beam is still important, especially for the most radiosensitive areas of our bodies. Nearly all of us have had some kind of diagnostic imaging, whether it be X-rays, CAT scans, mammograms, and remember your last dental exam. They place the heavy lead apron across your body, and it reduces most of the scatter radiation. Here are some examples of lead shielding aprons you might be familiar with. In recent years, physicists have determined that protective aprons can cause scatter to increase patient dose. It is now the formal recommendation of the American Association of Physicists in Medicine to discontinue use of lead shielding during X-ray exams. Here's the problem with that recommendation. Radiography is probably one of the medical fields that the general public knows the least about. Ionizing radiation isn't exactly a casual conversation like, say, diabetes management, having a cold, or even cancer. These are more common subjects. So let's break down how X-rays and X-ray photons work. Imagine you're standing up against the wall across the room from me, wearing a cooking apron, and I have a handful of those little bouncy balls you can get for $1 in dispensers. Now I throw them at you all at once. You're protected from the ones that hit the apron. But what about the bouncy balls that don't hit the apron? They go inside, and there's lots of back and forth bouncing going on after impact. But after they've bounced around inside your body, now they need to get out. And that cooking apron, it keeps them inside. A bouncy ball stuck, ricocheting inside your body, does more damage than one that can come out. Check out this diagram. Here you can see how those bouncing ball moving X-ray beams move. It's in their nature to rebound, and all faster than the speed of light. Now think how a barrier blocking part of the rays could prevent the ball, or X-rays, from continuing their path. These studies hit America's mainstream only January in a New York Times article, but most Americans don't know about this yet, let alone begin to understand the methodology behind a unique field with a unique part of their medical well-being in its hands. Truly what is most important going forward, this falls to the practitioners of radiography to handle this on a day-to-day basis. Think of it, every single patient, every exam, sometimes hundreds in a day, will come into a hospital or a clinic with a preconceived idea of how the exam will go to keep them safe. And scientists in this field are literally taking away what they think is their security blanket. I'm concerned for the health of these patients because I believe that many of them will refuse potentially life-saving exams without them. And a recent poll I conducted proves it. In an anonymous survey, 83% of respondents believed they would notice if they were not given a lead apron during an exam. And of those, 96% expressed some level of concern about it, including asking to speak with their doctor or even refusing the exam. All of this further proves that patients believe they need lead aprons to be safe. Look, radiography is great. It's sound and reliable science. X-ray techs have taken images in the last 100 years that have diagnosed diseases, broken bones, and everything in between, saving millions of lives. X-rays are also very safe. The radiation we get from medical X-rays is less than we even get flying in a plane or from the Earth itself. New discoveries have recently taught us how they can be even safer. The question remains, is the public ready for the change? I remain concerned and curious if over the next 20 years or so, more people will suffer from undiagnosed issues based on their hesitation to get diagnostic imaging such as x-rays, CAT scans, or mammograms now that lead aprons will fall out of use. I believe it will take a full generation or two to reteach professionals and patients alike that we can sometimes trust what we cannot see. After weeks of research and polling, I believe that when it comes to medical safety, perception is reality.